Okay, everyone, we're now going to move into some of the trigonometry ratios. And basically, I kind of mentioned this in an earlier video, but we're moving now into what is known as sine, cosine, and tangent. And if you have a scientific calculator or a graphing calculator, you're going to see you have an SIN button on there. It looks like sin, but we pronounce it sine. You have COS, cos or cosine, and you have TAN or tangent. And they are different, and they're related to the different sides of a right triangle. Now, what we're going to do is we're going to start off just with sine, and as this unit progresses, we will move on to cosine and tangent. And I'll throw in a few memory tricks here and there that'll help you differentiate between the three. But essentially, what's going to happen is we have to keep in mind how to name the three sides of a triangle. So that's hypotenuse, opposite, and adjacent. And when you have that in place, then you're going to relate that to sine, cosine, or tangent. So when we start here today, we are, like I said, we're going to do the sine ratio, and that's quite obvious. You can see it right here. And the sine ratio is very specific. The sine ratio is always related to the two sides, opposite and hypotenuse. Now, okay, so what's going to happen here? Long story short, in a following lesson, you're going to use the sine ratio to solve for missing sides of a triangle and eventually even an angle. So what does the sine ratio look like? The sine ratio, I know it's written there, but it looks like this. So it goes sine or sin, but we pronounce it sine. After that, you have an angle, okay? And then it's always opposite over hypotenuse. And so what's going on here? Well, eventually what's going to happen is, if you see these three check marks, angle, opposite side, and hypotenuse side, what's going to happen very soon is you will know two of those and you will have to figure out the third one. Now, before we get there, it's very crucial to know how to set up the ratio properly. So in this lesson, it's more not so much about finding a missing angle, it's about learning how to write this ratio in a proper fashion. So maybe the best thing we can do here is look at example one. So I'm just going to erase this. And we'll use example one to kind of explain how to write out the sine ratio. So it's solid practice to always just kind of, go with your blank formula. So sine of the angle is, you can just even go O over H, because we know that O stands for opposite and H stands for hypotenuse. Now, where do you start? You always start at the angle. Remember, identify the angle we are working with. And as you can see, sine of the angle. Where is that angle? It's right here. Okay. Your first step, always, no matter what we do, is to name your sides. Well, we've done this now a few times. As you can see, here's your right angle, and it points to the hypotenuse. So I'd recommend putting an H right there. The next thing that we considered was, well, here's the angle we're working with. And you know that the side across from that angle always is your opposite. And by default, we've used our O, we've used our H, now we have our A. So in this question, if I asked you to write the sine ratio, you simply would go like this. You'd go sine of our angle, which is this one right here. It's O over H. So what is the value of O? That would be 5, and your H would be 13. You have successfully written the sine ratio for this question. Now, even though it's not necessarily on this page, I would like to draw your attention to something here. What if, and I can't do it because this is on a PDF, but for what it's worth, just bear with me. What if I said to you all of a sudden that actually this is the angle that I want you to consider? So if you can, just kind of pretend this doesn't exist right now. If I wanted you to write the sine ratio now, so we'd set it up. So sine of the angle is O over H. Your first step is to identify your sides. Well, this doesn't change. There's your 90-degree angle, or your right. And as you know, it always points at your hypotenuse. Then you go to the angle in the question, and you go across, and we know that's our opposite. And by default, then that must be your A. So if you were to write it this time, it'd be sine of the angle. What are your values now? Your opposite would be 12, and your hypotenuse would be 13. And this would mean that you have successfully written out the sine ratio. You see, everyone, am I having you really calculate anything? No. What we're trying to do is to give you a triangle and have you write out the sine ratio in the proper fashion. Maybe what I'll do, let's just give it one more just for reinforcement's sake. So I'm just going to kind of erase this here. Sorry, it just takes a little bit. Let's draw another triangle. Let's go right here. I'll draw it right here. Okay. There's our 90-degree angle. Let's say we want to use this angle right here. And I'm going to say to you that this is 11, and I'm going to say to you that this is 15. So what I'd ask you to do right now is write the sine ratio based on the angle in question, which is this one right here. So sine of the angle is always O over H, or opposite over hypotenuse. So you have to identify your sides. As we know, this is your 90-degree angle. It points at the hypotenuse. So I put an H right there. Then you go to the angle in question, and we know the one opposite of that is your opposite. Fill in your ratio. So it's O over H, or 11 over 15. Okay? Think to yourself right now, what if I wanted this angle? How would that change? If I do it really quickly up here, that would give you sine of the angle. Remember, if all of a sudden now I'm asking you for this angle, sine from that angle, I think this would be your opposite over here. I guess I didn't give you a number. Anyway, it would be 9 over 15. I really do think that you understand this now, even though I can't see you. It's pretty straightforward, I think. Next, what we're going to do is just move down here a little bit. I want to guess, here's your answers here. 5 over 13 and so on. One thing that you can do, just so you know, it looks kind of confusing here now. You're like, well, what the heck's going on? What we've been doing so far is we've been finding the ratio. There are some questions, though, where they're actually going to want you to put that into decimal form. So if you look, we've done everything here proper. So if you look back to our original question, that would be your opposite, your hypotenuse, and your adjacent. We've done everything perfect. So sine would be, what is that? It's opposite over hypotenuse, 5 over 13. Just so you know, there are times where they're going to ask you to put this into a decimal form. That's no big deal, so just put that into your calculator and go 5 divided by 13, 0.38. That's exactly what they have here. So just so you know, there are some questions where they're going to say, take the ratio, take the opposite over hypotenuse, and simply put it into your calculator. Now, down here, this is really nothing new, but there are just two little warnings I want to tell you. Number one, see, this is where it's difficult because I don't see the calculator you're using, but you may want to work with your teacher and ensure that your calculator is in degree modes. See, when people do trigonometry, there's two modes that essentially are used. It's called radians and degrees, and it's different units of measuring angles and sides and ratios. The point is, if you're not in degrees, you can do everything right, but you'll get the wrong answer. So what I would ask you to do is, try these 4 here. And as you can see the answer here right now. But let me tell you something, if you're in the wrong mode, you will get the wrong answer. So I'm actually going to do this one wrong. You see, if you go sine 15 and you're in degrees, which you're supposed to be, you get 0.258. That's totally fine. On my calculator here, I'm actually going to put myself into the wrong mode, which is radians. And I'm going to type in sine 15. Let's see what we get. See, in radians, and this is wrong, in radians I get 0.6503. The point I'm trying to make to you here is if you keep getting the wrong answer, but you're kind of doing everything right, essentially means you're probably in radians. Please speak to your teacher to work on how to get your calculator out of that mode and into degrees. And finally, one little thing. It's funny, every calculator is a little bit different. As this unit progresses, you might find that you need to enter things differently in your calculator. If that happens, please speak with your teacher. I know it sounds weird, but every calculator is a little bit different. And